All right, today we're going to talk about angles inside polygons. So let's get started. Polygons have both interior and angles and exterior angles. Interior angles are the angles inside the polygon. You probably already knew that interior means inside. And the exterior angles are the angles formed by extending a side outside the polygon. So you probably knew exterior meant outside, right? So let's look at these two things below, and I'll kind of tell you here what interior and exterior angles look like. So first thing, you notice that all the sides were extended, all right? So these guys in here, and they're not congruent, so I'm going to kind of mark them like this. Those are exterior angles. So if it's in blue on my screen, I'm sorry, those are interior angles. Interior angles, okay? Or I'll just leave this guy with interior angles only. And then over here, we'll use red, and those are going to be your exterior angles, okay? So if you're not using color, just make your left figure your interior angles, make your right figure your exterior angles. So here's one, here's one. Notice they're outside the shape, outside the shape. And 1, 2, 3, 4, 5 outside the shape, okay? Now, if I went back over here, and if you're not using color, don't do that. This right here would be an exterior angle, exterior angle, exterior angle. And then over here, interior angle, interior angle, interior angle, interior angle, okay? So inside the shape, interior, outside the shape, exterior. All right, so we're going to talk about the measures of all those angles today, and things can get a little confusing. So what I did is I went ahead and put everything that you need to know in a little text box on your page. So nice and bolded, that's what you're going to be referring to when you practice these problems. So the sum of all the interior angles, so the sum of all these inside angles on a polygon, is this formula right here. Now, you know that the sum of the interior angles of a triangle is 180. You should know that the sum of the interior angles of a quadrilateral is 360, but we haven't talked about pentagons or octagons or 15gons or anything like that. So we have to have a formula to come up with it, and I want to kind of show you why this formula is what it is. So we know that here in this triangle, 180 degrees altogether. We just know that, we've studied it, we've got that one down. Well, if you look at a square or a quadrilateral, I could possibly bust this up into two triangles. Now, if I bust it up into two triangles, this triangle has 180 as its sum inside the angles, and this one would be 180. Well, 180 plus 180 then would then be 360. Now, you probably already knew a quadrilateral has 360 degrees as the sum of its inside angles, but I just want to kind of show you why that's true. So we can apply this to the pentagon, which has 5 sides. So if I just start at one vertex and I go across like this, we'll see 180, 180, and 180. And when you add all three of these interior angles of all three of these triangles together, you'll get 540. And let's look at this one. So let's just start one vertex. We're going to draw these triangles all from one vertex. Okay, and what happens here? We have 180, 180, 180, 180. And then this time when we add these together here, we get 720. Now let's look at the formula up here. Okay, 180, right? 180 times 1 is 180. 180 times 2 is 360. 180 times 3 is 540. And 180 times 4 is 720. But let's look at the sides. I have 4 sides, but I multiplied this by 2. I have 5 sides, but I multiplied this by 3. I have 6 sides, but I multiplied this by 4. So what we're multiplying by is 2 less than the number of the sides. So that's where this formula comes from. Now you don't have to regurgitate or do this over again for me. You'll never have to show this. I just want to show you where this formula comes from. So it's 180 times the number of sides and subtract 2 off of that. So let's go ahead and use that down here. Now it says solve for x, but before I can even solve for x here, I need to know what all these angles add up to be. So in other words, I need to know what the sum, that's what that s is, of the interior angles are. And we know that the sum of the interior angles is 180 n minus 2. And n is the number of sides that I have here. So 1, 2, 3, 4, 5 sides are what I have. So n equals 5. So we'll substitute that in there. And so we know the sum of all of these will give us this number, right? So we can say the sum of the interior angles equals 180 times 5 minus 2. So the sum of all the interior angles will be 180 times 3. So the sum of all our interior angles here then will be 540. Now you're not done because it said solve for x. Read those directions. So we know all of these will add up to 540. So all of these will add up to 540 degrees. So that's what we're going to write out on our paper. So let's start with the 99. So 99 plus 132 plus x plus 107 plus 94 equals 540. Okay, so before we could even come up with that equation, we had to figure out first what the sum of those interior angles are going to be. Now back in the day when we did triangles, it was easy. You just knew it was 180. Or when we did a quadrilateral, it was easy. You just knew it was 360. But now we have pentagons and octagons and 45 gons and all kinds of crazy stuff. So you're going to have to use the formula to find out what the sum is going to be. All right, so let's combine our like terms. So we have x plus, if I add all these up, I get 432 equals 540. And then what I'm going to do to both sides is subtract 432, and here I'll get 108 degrees for x. So there are two parts to this problem, and a lot of people skip it, and they do really weird things, so just make sure you understand what's happening here. The sum of this is 540, so we set it equal to 540. What I want you to do is do number 2 for class, so come with number 2 completed for class, and we'll talk about it when you come on in, but have that finished for me. You can pause now and work it out, or you can wait to the end and work it out. All right, we're going to keep going down to the back side of the page. So what if we just want one interior angle? And by the way, we're only dealing with regular polygons in this formula right here. But if we just want one interior angle, if we want to know what each interior angle is, that's what EI is, each interior angle is. Think about it. If I have a triangle, now you don't have to write this down. If I have a triangle and it adds up to 180, if I want to know what just one of these is, well, I would take 180 and divide it by 3 because there are 3 angles there. Same deal here. So we have the sum of all the interior angles, and what we're doing is we're dividing it by the number of sides. Isn't that what we did here? That's the sum. We're dividing it by the number of sides or the number of angles. Okay, so basically it's the last formula divided by the number of sides or the number of angles. So let's go ahead and try this one down here. What's the measure of each interior angle in a pentagon? Well, first you have to know a pentagon has 5 sides. And once you know that a pentagon has 5 sides, you know that each interior angle is just the sum of all the interior angles divided by however many angles there are. By the way, the number of angles is also the number of sides, so that's why I just used my n. Well, we know the sum of the interior angle formula is 180 n minus 2 over n. So we're going to go ahead and substitute in 5 for all of our n's here. So 180, 5 minus 2 over 5. 5 minus 2 is 3, so we have 180 times 3 divided by 5. You're cleaning up your numerator before you divide. 180 times 3 is going to be 540. And then we would divide this by 5, and we would find that each interior angle of a pentagon is 108 degrees. Each interior angle. So I'm going to write in red because you don't have to write this down, but it's as if we had this pentagon, and I just want to know what that is. And now I know that that's 108 degrees. Okay? What I would like you to do is find out what the measure of each interior angle of a hexagon is. So do that one, bring it to class. You can pause it now and do it. You can do it at the end of the video, but go ahead and work out what a hexagon would be and bring that to class. So I'm going to move down here. The sum of all the exterior angles of any kind of polygon is 360. So don't ever get this wrong. You don't have to calculate anything at all, and yet I have students that will get this wrong. And let's think about why. All right, so if I have this triangle right here, I know that's 60. I know that's 60. And I know that's 60, right? Because we're talking about a regular triangle here. Well, if I talk about this right here, that's a straight angle. And a straight angle adds to 180 degrees. So if this one's 60, 180 minus 60 would be 120. Okay? Same thing here. Straight angle, so this must be 120. And this is a straight angle, so this must be 120, like that. Well, if I add 120 plus 120 plus 120, I end up getting 360. Now I can show this to you with a rectangle, with a square, and with a pentagon, a hexagon, a hundredgon, and any of those things. And I promise you that every time we do it, when you add up all those exterior angles, you're going to get 360 degrees. So don't miss this one. That one should be pretty easy. We're not even going to talk much about it, but when you have problems in class that say, hey, I've got this, I don't know, 11gon, what's the sum of all its exterior angles? You just say, boom, 360, and you're done. There's no calculations. Well, let's think about this, though. If I just want one exterior angle, you know, if I have this shape, and here are all my exterior angles, right? And I just want this one. Well, wouldn't I just take 360, which is what all of them are, right? And wouldn't I just divide it by the number of angles or sides that there are? So if I just want one of them, I just divide it. Where this is coming from, it's basically the sum of all your exterior angles divided by n. Now think about that in comparison to the other formulas. Over here, we had the sum of interior angles, right? And then if we wanted each one, we just divided it by n. Here we have the sum of the exterior angles, 360. And if I want each one, I just divide it by n. Okay, so it's just the one formula divided by n. So I'm going to go ahead and do number one. We have a 15gon here. We just want one exterior angle. So n is the number of sides. So each exterior angle would be 360 divided by n. So that means each exterior angle would be 360 divided by 15. So each exterior angle then here would be, once I calculate that, 24 degrees. What I want you to do is do number two for class. Complete number two and bring that to class. You can go ahead and pause it here and do it, or you can go back and do all of them at once, but bring that to class. And there is one more type of problem that I'm probably going to talk about in class 2, and I'll see you then, and I hope you had an amazing, amazing time. See ya.